Okay guys, in this tutorial we will be making this bracket. It is called a C-shaped bracket in Creo parametric. Creo is basically a CAD software just like any other software like CATIA, SolidWorks. So you can use whichever you want. I'll be using Creo, and then we will be exporting this bracket in Ansys workbench, and we will be doing simple analysis, static load analysis on the bracket. So let me give you a brief view. What is a C-shaped bracket? So here you can see, if I try to zoom in here. So this bracket is used over here on this to hold this wheel. So it's almost like this, almost similar to this over here. And then some shapes I can show you here. This is also same C-shaped. So they can be used for holding static structures. They can be used in fixtures to hold something, or they can be used in mounts here to hold this wheel. So, so it is very important to do the analysis to see the amount of force which this bracket is carrying, the stress which it is carrying, so that there is no, such that this bike, for example, does not undergo any catastrophic failure and does not injure the person who's riding it. So, so let's start making this. So this is the sketch. I will be creating the sketch. Okay. So I'll open a new, mm, uncheck this. Okay. So these means is mm meaning millimeter, Newton second. This is inches, in meaning inches. So we will be using a millimeter Newton second. So we will be creating a part. But for me, it doesn't work in this software. It doesn't work from here. So what I will be doing, I'll be clicking on this empty and say okay, and then I'll close this, and then over here we will go to prepare and model properties, and here you can see the units is in inches, lbm second. This is the default in Creo, so we will be changing it to millimeter Newton seconds. I like to work in this unit. So basically here it is telling, if I type in 1 it becomes 1 mm, so I'll be selecting this. So if I press the number 1 it will become 1 mm. Okay, close this, and then material assign, not assigned, so we will assign it later. From here you can see here there are many materials, aluminium, brass, copper here. So we will first create the structure, and then we will assign the material. So let me close it from here. So we'll select the plane, and this is the top plane. Okay, just select this, right, left click on this, just left click on the top plane, and then this is extrude, left click here, and then we will go on sketch view. Yeah, sketch view. So yeah, so where is our picture? So here we can see, we'll make this. So this is 80 plus 20 plus 20, so 120, and this is width is 80, and depth is 15 mm. So these are all in mm. So I will take rectangle, center rectangle, okay, and press the scroll button to exit, okay, and now double click on this and from 120, press enter, double click on this is 80, enter, okay, and then we will say okay. So now we have to adjust the depth. So depth we can adjust from here. So depth is 15, you can see here 15 mm. So we'll type in 15, okay, and then click this. So this part is done. Now if I shift and scroll button, then I will be able to pan this, and if I press shift and control, then I will be able to zoom it, and if I press control D, then it will get in this home. This is called home view something, okay. So now we will be making this circle, this part. So here this is 80 mm, okay, and this is a depth of 20. So again select this surface, again click on this extrude, and then click on circle, center point circle, okay. Now it is automatically, it is selecting the center here, and just click once, again click and hold the scroll button, press the scroll button, okay, and then this will we will give 80, enter, and click ok. So here now we will give the depth. So depth is 20, okay. So 20 we will type in and automatically it adjusts. Say okay. Now there is a cut, a depth of cut is there. So this the inner circle is 60 and this depth is 15, okay. So the 15 cut is there. Hmm. So we'll select this end with, sorry, this surface, and click on extrude, and then again we select the center point circle and draw, and we will type in 60, okay, 60, and say okay. So we want to give a depth of 15 and it should cut. So what we will do, we will first give the depth 15, okay, and then remove material. This will give a depth, and if I, and this is for remove material, so that if I press it will remove material, and this is basically the will give the direction whether we want it on top or down, and this is remove material, okay. So click on ok. Hmm. Okay, so now what is remaining? Okay, now we have to create a hole inside. Inside this we will create a hole. So to create a hole is 30 diameter. So again we will select this surface, okay, and then click on extrude, and then center point circle, again catch the center, we'll draw the circle, hold scroll button, press the scroll button to exit, and then double click on this and give the radius 30, I suppose. Let me check. Yeah, 30. Okay. Now say okay. Now we will just reverse this, and then you can see remove material is already selected. So if I unselect this, it will disappear. It will fill this, and if I select this, it will remove the material. Okay. So click OK. So this part is done. Now, sorry for the disturbance. Now we will make this part. Okay. So for that I will click on this space and I will extrude and then sketch view. Okay. So let me adjust it. This again I'll tell you, press the shift button, scroll button, and then you can adjust it, pan it. Now we will give reference to this side, these two, sorry, here. So I'll press this edge, and this edge will give a reference plane. Okay. This reference plane we are giving so that the cursor, so that while drawing it or drawing any the rectangle, the cursor can catch the end points. You see, it is able to catch. Otherwise, in some cases, actually you don't need this in Creo 5. It automatically catches the edge, the vertex. Hmm. But if you're using an older version, it is not able to catch the vertex. So it's better you give a reference line. So let's draw a rectangle. Okay, and then press the scroll button, and let's give the uh, since how much it is, 50 it is. So yeah, 50. Okay, and now I'll click on this line and I'll click on this icon, so it will create constraint. Okay, now here, now between these we will draw an arc. So we'll draw this center and ends, this type of arc. So click on the center point and click on this end point, and it will click on this end point and it will generate the arc. Okay, press the scroll button to exit, to come out from the arc menu. And now it's asking, there is a circle of 32 mm, so we will draw that. Again, center point circle here, and then this will give 32, enter. Okay, and say okay. So again we have to adjust this width. So it is given here 20 it is, so we will first adjust that. Type in 20. Okay, and we will click on this icon, so it will go inside here. See the difference? It's outside, it will go inside. And say click OK. So control D, we will give this basic view, home view. Now we will mirror this part on the other side instead of drawing it. So extrude fifth one, this is already selected here. This green lines you can see it's already selected. Click on mirror and click on the plane. So this plane we want to mirror. Then you can see it automatically generates, and then click on this tick, and then you can see it is generated. So we will give some round so that it's very sharp. The edges are very sharp. So we will apply round. So from here we will apply round all. And then we will give a round of 5 mm. Okay, Press this enter. So this will apply for convex and concave rounds. This is concave round, this is convex round. Okay, and then if I click on OK, it will generate the round. Here, there you go. So this is the round generated here. Now, now we will give some appearance, some color to it. This is just for aesthetic views. So for example, here appearance, go on view and click appearance, and let's select this. Sorry, first select this object, and then click on this appearance here. So here's a bracket. So now we want to import it to Ansys. Okay. So before importing it, sorry, exporting it to Ansys, we have to save this. Otherwise, Ansys will not be able to read this block. So we will go on here, this icon save. Okay. So I'm working in D. I will save it in D drive. I'll show you D, and then here Creo. Actually, it is Creo 5. I was using Creo 6, but it had some problem with Ansys, so I downgraded to Creo 5. So I forgot to change this folder name. So I'll just save it here. Okay, and it got saved. Mm, here you can see your part 1 already saved. Okay, now to get this option in Creo parametric Ansys option, you have to do little setting. I've already done it, that's why I have it. So um, so what you have to do, okay, minimize. So just type in CAD configuration manager. Okay, this only this process you have to do at the beginning, to configure. This basically integrates Creo with workbench with Ansys. So you have to do this. This actually should be the very first step. So you have to basically close all the application, Creo and workbench, Creo and Ansys. These applications should be closed, and then you search here CAD CAM configuration, and then you have to make the integration. So this has to be the very first step, okay, before creating any part or anything. Very first step. So what we will do? So here we will select on Creo parametric. See, there are many options here: CAD, CATIA 6, Solid Edge, and SolidWorks. So I'm using Creo. Okay. So I'll click on Creo. Next, and then here it is showing an option. You have to just browse in this location. Okay. For example, C program files PTC Creo. You have to just browse to this location and just paste it. And just go over there. Okay. And same thing over here. Just browse and keep, and then say next, and then you have to click on configure selected CAD interface. So I will not click on this because I've already done it. Hmm. So so you will get a message here, configuration successful. Okay, 2 times you'll get message here, configuration successful. So I will not be doing this because I don't want to screw up my configuration again, because sometimes it works, it doesn't work. I tried doing it again, so I will not be doing this. Hmm. Only this thing you have to do at the beginning. So now, then when you open Creo, you will get this option Ansys. Okay. Now we will export it to Ansys. Just go we were in model. Just click on Ansys, and then click on workbench. Okay. So it will open workbench. So it will take time. My PC is actually very slow, low hardware PC. So I'll skip this part for you guys for to save time for you guys. Okay. So as you can see, my geometry has been exported from Creo to workbench. So you can see if there is a green tick mark, meaning so good, everything till now everything is fine. There is no errors. If there is some cross mark or some other symbol over here, then maybe some error might have happened. So you should have a green tick mark here. Hmm. So we will be doing static structural analysis. So this is the option, static structure. So just click on it and drop it on the geometry, and now leave the button, and it Ansys will automatically combine them. So it will take some time. My PC actually is very slow. Here you can see here it has already made the connection, and now so we will right click on model. Okay. Okay, one more thing here. So here we did not give what material is this. Ansys will automatically take this material as structural steel. So we will give we'll basically name this we'll give what type of material this is. So we'll go here, prepare model, and then here material not assigned. So we will assign a material here. Okay. So here legacy material. So we'll just give aluminum. Okay. just double click on this and then say okay. So here you can see aluminum. Hmm. Click okay. Now go back in workbench. Now right click on this, go on properties, will go on properties here. Okay. And here select material properties. Okay. So it will automatically Ansys will now read the material properties. Hmm. So now right click on this and we'll edit it. Okay. So here our material has been imported. So now if we click on this geometry plus, okay, and click on this part, so here it will show us the material assigned is Al aluminium. Okay. if if in Creo we did not, if we don't assign any material in Creo, where it went, here, prepare, yeah. If we don't assign any material here, then what will Ansys do? It will automatically uh, take this material as steel, structural steel. It will automatically treat this object as structural steel. But we have already assigned it, so aluminum we will be using. Huh. So, but for this application, so yeah, so the scooter which I showed you earlier, we don't use aluminum brackets because it will, the aluminum is actually basically very light and it's not very strong. So it will so if anyone stands on it, very heavy person will break. So only for just for analysis purpose, we are using it. We are taking aluminum, okay. But the scooter which I showed you earlier, we don't use aluminum to for that, for the wheels, to mount the wheels in between. Okay. So now we will generate mesh. Okay. So meshing is the first part. Okay. So for mesh, just click on this mesh, right click, and then generate mesh. Okay. So Ansys will generate a very basic mesh, and it's not a very good quality. Hmm. So here, this is the mesh generated, but this is not a very good quality. Hmm. So we will make it a little better, but not extremely good because my PC will not be able to handle the load and it will crash. So you basically need very high uh, hardware to run Ansys and to run such CAD software and analysis software. So what we will be doing, we will be right. We will go on mesh, select mesh. Okay, then this go on this object, right click, go on insert, and we will go on sizing. Okay, now in sizing we will select the geometry. Okay, so we want this whole geometry to be selected, so we will go on this body. Okay, and now if I click on this, the whole geometry is selected, and click here and say apply. Okay, now here default we will give 5. um, it will still take very long time if I give 5 to process it, so we will give 7. Okay, and then we will select here the soft, we will make it too hard. Okay, and then if I click on mesh here, if I go here in sizing, uh, actually make this transition will make, actually we have to make it too slow, but I will not be doing it because again my PC is very low configuration, and here span angle center should be fine. Okay, I will not be doing it to fine, I will be doing it on course. Okay, this we can do here. Quality, is on medium, but if you have a very good PC, make it on high. I will keep on medium, and these you can leave it as them as that is. Okay, so we will update it. Okay, so okay, so here you can see. Okay, so it's little more better, but still this is not preferred. Your meshing should be of very good quality. Again, I'll try to make this little more better. So body sizing, I'll click here under mesh, and I'll make this to 5. Okay, and press enter, and then again update. So if I click on mesh here, then you can see it's more fine now. Hmm. I'll not be going lower than size element over here. I will not be going element size, not I will not be making lower than 5 because again it will take very long time. Okay, now we will go on static structures. Okay, now over here we will right click on this and we will go on insert. Now you get a whole list over here, so we want to insert fixed support. Okay, so we'll click on fixed support, and now it is asking over here where you want to apply the fixed support, so we have to select the face. Okay, so we will select this face. Again you can see it is selected, and click on apply. So here you can see fixed support is selected. Hmm. Now again we will go on static. Okay, now right click, insert. Now we will apply force. Okay, so where is force? Yeah, force. Okay, so we will apply on one face first, and then we will apply on the other face. This face apply, Okay, give 100 Newton. Now, yeah, now the direction we want to give. So basically the direction is showing outside, but we want to apply force inside. Okay, so just press on this and click OK. So now the force has been applied on this body, okay, in this direction. You can see the arrow. Okay, now again we will go here, go on insert, again force. Okay, now we will select this, again type in 100 and give the direction. So direction, you click on this. Okay, now direction is on this face, and say apply. So now, okay, yeah. So now in this static structure, we can see the fixed support is given over here in blue color. Force, the first force is on this face, see inside, and the second force is here. Okay. Now we want, now for under solution, we will be doing total deformation. We will select. You can select it from here, or right click, insert, and deformation, total deformation. Okay, and stress. So you can select stress from here. One miss, one misses, but I'll I'll do like this. Insert stress. Okay, equivalent one misses stress. We will select. Okay. So now everything is fine till now. You'll see small ticks over here. Here small ticks. So it shows like everything is fine. So now we will solve by clicking this. You can see the progress here going on. It will take some time. Again, this is very basic. This is like very basic. Okay, so it has finished the analysis. Now we can see here. So if I click on total deformation and if I play this, so it will show us how the deformation is occurring. And here we can see the maximum and the minimum deformation is happening. So I'll pause it over here. So here you can see, you can match the colors. So this red section here. So maximum deformation is 0.00.006 mm. Here unit is in mm. So that is the deformation. Okay. So and if I see on stress, so unit is in megapascal. Again, you can see the stress, how the stress is acting. If I try to pause it here, yeah. So here, this area is maximum stress is appearing on this area, the red section. So it's 1.7795 megapascal stress here. So if this model has to fail, was supposed to fail, it will basically fail from this area. Hmm. So again, if I play and show you, here see, again I'll try to catch that red surface. Here you can see here stress. So this is like simple analysis you can do. Hmm. This is the deformation here. This will be having the maximum deformation here. Okay, and stress, and here will be the maximum stress, and here will be the maximum deformation. Sorry for that. That is one idiotic friend of mine who's calling my name. So okay, thank you for watching this video. So this is very basic, very simple, and even meshing is also not very good, because I told you, because I can't generate high quality mesh, because due to my configuration limitation, my PC limitation, very low hardware. You basically need very high PC, very high Core i9 type of configuration. Okay, thank you.